Hello there, my name's Nigel Griffiths. I work in IBM Power Systems in the UK. There's some contact details at the bottom. Now, I must point out these are my personal opinions, but it's what I found out when I looked at IBM Garage Methodology, and I learned some new tricks for njmon. njmon is my performance monitoring tool for AIX, the VIOS server, and for Linux. They're all on Power. The Linux bit also work on x86 type platforms. In 2021, IBM is outputting sort of different messages about the areas that it's focusing on. We have a new company called Kyndryl, and that's going to focus on managed infrastructure services. And that actually describes exactly what it's doing. It can be IBM's infrastructure, or it can be anybody else's infrastructure. We have little jokes at IBM that every presentation has to say something about hybrid multi-cloud with AI, and so there we are. We've got that out of the way. Now, for me as a power guy, I've been using this thing called Power VS. This is in the IBM cloud, but it's a virtual machine, very much as I'm used to dealing with it in my own computer room, or if you want to be hippie about it, on-prem. We have AIX running in there, along with Red Hat and OpenShift if you want to use containers and Kubernetes in a professional way. Another thing we're refocusing on is something called the IBM Garage Methodology. I thought a methodology was a study of methods, but no, I'm wrong. If you look it up in my dictionary, if you have a collection of methods, then it's a methodology. Then I'm British and I use garage to mean a place where you park your car next to your house, and our houses are fairly small in the UK. My one's got a motorbike and a bench with hundreds of tools on top. I can't never find anything, and the rest of it is used as storage space. But no, we're actually talking about IBM Garage here, a posh garage. You might have seen in American movies or TV series that somebody might have a garage which actually can hold like 4 cars or so. It's big, it's brightly lit, it's painted floors, everything is beautifully laid out in here. They got a lathe in the corner and a professional drilling system for cutting the metal in exactly the right way, and all the tools laid out, probably all against the wall, all labelled in all the right orders. You can always find your right tool. This is a professional garage, and they're going to perhaps rebuild a Model T Ford or something in the corner as a hobby. It means though in a garage you have the right tools readily available, all organized, and you have the skills to use them before you start doing your project on perhaps a car or something. So remember that, it's a garage. In IBM, we use this word experiential, and I thought, that's another made-up word. What are you talking about? No, it's actually a word, and I looked it up in the dictionary. It means involving or based on experience and observation. So the idea is we use a garage, work with our customers to jointly rapidly develop a solution to one of their business needs. And we can show off in this experiment the garage methodology and how we can quickly build new programs, applications based on Red Hat and OpenShift and container technology to make them very flexible and rapidly develop them with new functionality so our customers can put those new ideas into their applications to aid them fight off their competition. So as a developer for many years, this sparked my interest. This is like my home ground. I still do development of things like nmon and njmon. But I don't want yet another 5 to 20 minute video full of buzzwords and what are the benefits. I actually want to find out, how does this thing actually work? How is the garage methodology better than what I used to do? Well, this is a bit of a confession here now. I've been developing for 40 years. But that's old school. What are the new guys in town doing when they're actually doing development? And it's quite an amazing thing. This video is about my learning about what they're actually up to. Inside IBM, we have a service called Your Learning, and on that you can go and look up courses or education or videos that would actually help you do your job. We're big into developing skills. In fact, in the first 4 months of this year, I've had 4 weeks of training, all remotely, of course, at home with the COVID virus sort of problems we have, but definitely learning quite a lot. So I put in Garage Methodology, and here it came up a course, and I thought, this looks pretty good. This is what I'm actually looking for. Here's the URL at the top. I'll put that in the video notes on YouTube. But it actually makes sense. Look, IBM Cloud Architecture Content Course, Explore Garage Methodology. And then I noticed down here it says 8 hours. Well, that's not too bad. I'm not going to do it all in one go. I'm going to do 2 hours to 3 hours a day over a week. When I actually did it, I learned that it took a lot longer than that. 15 hours, I reckon. It was difficult to add up the actual hours. But there's lots of new content and a lot of thought-provoking ideas about that's different. Why is that different? How is that better? All right, now I get it type activity for me. Maybe they like putting it down to 8 hours, so a lot of people get started. Once you see the content, you want to carry on, no matter how long it takes to actually get the full course done. There's actually 75 modules in here. Each of them are different web pages. You could think of them as chapters. Some of those web pages are actually, I've got a 27-inch screen here, so it's quite big, but it could be like 8 to 10 pages of dense, large paragraphs of content to get through. There's also links to lots of other content. There's 3 one-hour videos that you can watch from some real experts at IBM about what's going on with these new tools and things. I actually used in my Chrome browser the Read Aloud plugin. So this allowed me to mark up, 4 or 5 great big paragraphs and get a very pleasant, I think she's an American lady reading it out at me. Can be quite good fun with some complex sentences that it'll actually sort of pause in the middle and you can almost feel the AI engine over there trying to work out how do I say this sentence, and it gives it a go. Sometimes it's not quite right, but it's quite good fun. The other thing is that it's a badge. So at the end of this course, you actually get a nice badge. My manager likes me to have lots of badges as a proof of your experience and your skill. So this was hitting all my buttons. Now the modules, this is going to be a bit of an eyesight test, so I'll quickly put those up on the screen now. Now I'm not going to go through all these in great detail. If you go to that webpage, you can go and read them for yourself. And just make a few observations while we're actually here. First of all, you'll notice there's 7 ones there that says test your knowledge. That is actually an exam, multiple answer questions. And it's quite a lot of work, to be honest. If you add them up, there's 7 tests in total, 100 questions. So that gives you a clue. These people knew what they were doing in their writing, making them out 100 different questions. They do cycle around if you get them wrong and things. You're allowed to retry them once or twice every day, and then you have to wait for the next day if you're still getting the answers wrong. But once you get through all the content and all the tests, you really feel like you've earned your badge. It's not just given away to anybody for turning up and staring at a screen for 10 minutes. Now here's my sort of overall plan in here of the different sorts of things that are covered in here. A lot of these topics are actually big topics in their own right. So we start at the top left, we got the introduction to Garage. I said that right, didn't I? Then we got Agile Computing. That's a whole new course area in itself. I've read up some of those sort of things in the past. So how to actually make sure you focus on what the requirements are, not what the programmers want to do. Some tooling to support all that. DevOps 101 is down in here. If you look at the 3rd and 4th column, it's got develop and operate. So that's the real DevOps over there. Cloud changes the way you do things as opposed to my sort of old school, great big single application released once every 3 years. Focus on the business goals. We've got design thinking. That's a big item in IBM about how we approach breaking down computer problems into manageable chunks and working out what the outcome should be. Personas, that's working out, Jane and John are 2 different sorts of user and what they're things that they need out of the system and how they measure the success factors. A lot of MPVs are out now, minimum viable products. This is how do we release the first official release of a program with enough functionality so it actually hangs together, and then we can add the pieces, the more complicated functions over a period of time. User stories goes with the personas. Then we have tool evaluation that the agile and design thinking people will need. Then we go into the development, test-driven development, completely different way of doing things. I mean, I like to write the code and then run out of time to actually do a lot of testing. But now we write the tests, and then you only write code if it's required to get through the test. Really cut you down to what it really needs to be implemented, and then you have some great test harnesses to actually test that those those things, the tests are passed with every change you make to your application in the future. Rank order backlog. This is how you manage a team of programmers and highlighting which are the important tasks they've got to do next, and they pick those off the list. Then we have the continuous integration and continuous delivery is covered in here. Also how to integrate your artificial intelligence, your machine learning type functions in there to get some really exciting applications. Auto scaling, this is in the operate now. This is the containers and Kubernetes way of doing things, running more and more containers if you're running out of CPU and memory, for example. Site reliability engineering is another big subject. We see quite a lot of adverts for SREs. This is how we scale up our big warehouse full of computers, and we don't have thousands of people running around fixing them. We have automation and lots of tooling to actually run a very clean site. HA, that's the high availability side of thing. Now, if you're actually running your application and improving it and adding features to it, then you're doing this hypothesis testing. So you might say, well, people are having a problem with this part of the application. If we change the way it works slightly and ask the questions in a slightly different order, maybe we can get customers happier with it, and we can then write a version of the program to test out this hypothesis with 1% of the users, gauge is it the right thing to do, and then roll it out to everybody if it's a success. Then we have this A/B testing and releasing, so we can try users on the newer code, the newer function, maybe special users that are going to give you a lot of feedback, and then if you're happy with it, then you can roll it out to everybody else as well. So big different way of doing development. So I learned a lot by going through this course, and I'm just encouraging you to go and have a look if this is of any interest to you as well. We actually, when you saw that badge, it had a little 3 ticks on it. So this is the first one. If you want to go on and do more garage education and get a badge, you actually have to join a garage team. So I wholeheartedly recommend it, particularly if you have some development experience and understand the problems and the issues and the beautiful fixes we have in the Garage methodology. Now, once you have your badge and wear it with pride, well, what next? Well, that got me thinking. So I wanted to go one further level deeper into the IBM Garage methodology. And so here I found the top level web page. This is all perfectly free and available to everybody. And look at that URL. That's really strange from IBM. That's obvious. IBM.com Garage Method. You don't really have to write that down, do you? So I found from here you can launch into much more detail of this methodology. And the 3 buttons in here are the co-create, co-execute, cut off the bottom, and co-operate in here. And then these buttons in here are the 7 things in here, and so the monitoring of your applications running appear in this one here, operate. So if you go into this, you then get 4 pages of more detailed articles, if you like, on operating your computer. Now, I'm not going to go through all these. And then there's another load of tools as well. And if you actually go back one level, so down in here I found monitor your applications by using the golden signal. Okay, that sounds about right, but what's that about? Click on there, you go into this page. You can see the actual URL up at the top if you don't want to go via the top page. And a whole load of things that really had to make me think. I'm going to read the top sentence to you. Many of the traditional performance monitoring techniques are ill-suited to monitor microservices. What? My tools aren't any good? Monitoring potential causes such as CPU, memory, and file systems are frequently irrelevant due to the embedded resilience nature of cloud native architectures. And I had to read that 3 times. I think I know what they mean. If you're running containers and if you run out of CPU, you can spin off another set of containers. They will probably end up on different CPUs, on different servers in your computer room, so you can grow very rapidly. So monitoring a CPU and memory isn't so important. You haven't got a hard limit. If you hit the hard limit, you're going to stop the performance growing any further. It will self-manage those sorts of things. Not so sure about the file system, but we could automatically allocate more disk space if the database runs out of actual space, so I can buy that. Okay, I can accept that for now. Right, high utilization isn't an issue if your service level objectives are being met. Well, that's true old school and new way, so okay, I can sign up to that. Now, they call them the Google's 4 golden signals, and their latency, traffic, errors, and saturation. Now, I've copied the details that they had in here, but I've shrunk it all down and took out all the extra words that you don't actually need, because I don't want to be polite. So, latency used to be called response time. That's important. Measuring the latency between microservices, the various parts that make up your application. And it said, make very careful to point out, and the overall user response time. Well, I'm very aware of that. And you need to establish a baseline on normal operations, how long your transactions are typically taking, and then monitor. If that suddenly starts growing, then you've got a problem. And it said, don't use averages, because, as I've seen with my tools, if you start averaging them out to like once an hour, all the ones that really hurt customers they got to settle down disappear when you average it out across an hour. So it said use your 95th or 99th percentiles. That's highlighting the ones that aren't normal operation in your computer. Okay, next we have traffic limits. Traffic is the amount of activity of an application. Examples are for microservices, the number of API requests, the connection requests to database services and things, and your network packets, or the communication in between the parts of your application. Fair enough. Error rates, that's good. Yes, I want to capture those if I could. So things like if you've got a REST API that produces, 200 means perfectly good. If it's anything else, it's a disaster. So monitor those. And even if it says that it's a code 200, which is everything was working fine, sometimes they return the wrong results, for example. So try and capture those. And they can expose very quickly bugs in your application or poor configuration. Maybe you need to create more containers for a particular part of your service, or missing components. Did somebody switch off a component and it's not there and it's just returning errors all the time? So very good to monitor those. Then it said monitor for saturation levels. So once a computer resource is fully used, it just doesn't go faster, does it? That applies to CPU core threads, memory, disk I/O, network I/O, garbage collection for things like Java, for example. Now, usually that's measured in a percentage utilization. Once you get to 100%, you can't go any faster, right? Unless you allocate more resources. And for disks and networks, there can be sort of theoretical maximum line speed for a network, or disks. They can't do more than so many reads and writes per second. So you want to find out where that is. That will be marked as your 100%, and you'll want to monitor how far you get towards your saturation levels. Now, saturation levels are hard to implement for application limits. I've added this for my ideas in here. You may have serialized parts of your algorithm so that they can be caused a bottleneck. If that's not the core part of the algorithm, then that's fine, but you can catch yourself out. Latches and locking can produce strange effects in your applications, that they don't go as fast as you might hope, or they don't scale up as fast as you want them to. Keep in mind, it said that quality degrades before actually reaching 100%. On my power servers, we quite often run at 90 to 95% utilization on our big servers, because you have so many transactions and they average themselves out, and so we can hit those high numbers. I know some other infrastructure computers, a lot of people will say, no, if you go above 60%, you're not going to get a reliable service, but we can do better than that in power. In this description of these golden signals, it had this graph in here, and I thought, wow, look at that! I can see the top logo. That's Grafana. That's what we're using for njmon and nimon. A little bit about nmon you should already know. Run on AX virtualized server and Linux on any platform you care to compile it. It's saving the data to a time series database. And then at the back end, Grafana to generate the graphs, and these are some little examples. Also, if you've got some stats that we're not collecting, perhaps you can run a command or a shell script to find out something like the number of transactions your database is doing every second. Then you can use this little command called nmeasure to push those into the njmon database as well. well. So how are we doing with njmon for these sorts of things? Well, for traffic between REST APIs between your microservices, no, we don't do any of that. Networking, eventually you're going to have to go out to the user and back. We covered that already. On the saturation side, that is the CPU, the memory, the disk, the networks, and a whole bunch of other stuff. We're doing that pretty well for the OS and hardware side of things. Don't do saturation of your application, of course. But if we look at these other two, the latency and errors, that got me thinking. And it's nice to have some tool that makes you think harder about what's going on in here. Maybe we're missing a trick. So on the errors, I suddenly realised this morning that actually we don't actually want to log the errors and the text of what's in them. That's that sort of logging service rather than performance monitoring. But we could just capture the number of entries in the log. And if that suddenly starts going up, that might explain why your performance is going down. You might have things like disks going flaky and we have to reset them. We might have processes crashing and other things. The error logs will quickly rise and we can actually spot that in a performance stats. Very easy to implement. That's going in on the weekend. Now the other one, the latency side, that's harder. Now, we can't really put into a performance monitoring tool transactions, So we're looking for some sort of little transaction that regularly works on your operating system. And yes, we actually have one. We can monitor the response time, if you like, of njmon as it's running. We actually capture the execute time that it spends running because we want to try and do the output of the stats at a regular interval. Typically it's 30 seconds or once a minute. And so we actually measure how long it takes to run, and then we offset that, reduce the amount of seconds we wait until the next snapshot to make sure that we keep the snapshots in sync. And this is an example of a synthetic transaction. It's not the real one for your application, but it will highlight when the CPU time is hard to get. So I ran a test against this, and this is what we got. I suspect this may be too much information for just having your video. So we're going to concentrate first on the bottom left. So if we drill in there, down the bottom in here, we got some fake workload. This is NCPU, part of my NStress toolkit. It's a CPU hog. So we're going to run one process and two processes and three processes. It's going to run for 130 seconds. That makes sure we get at least one good snapshot for the whole period. And we throw in a little bit of wait time, snooze time. Applications don't run 100% on the CPU. They usually pause waiting for something to happen. So this gives us a bit of a flutter in the workload that more accurately represents real workloads. We can see when we get to about 4 tasks down in here, we actually start using a lot of the CPU time. When we're using 3 or 4 in here, spinning tasks, then we're using 1.8 of our virtual CPUs. So here we have 2 virtual CPUs, and so that is how big the LPAR actually is. If it's uncapped, you can use up to that. This LPAR or virtual machine is guaranteed 1.5 CPUs worth of time. So up to here, absolutely guaranteed. If it wants it, it'll get it. Above here, then we're going to compete with other virtual machines on this computer, and it will get up a portion of its time. In this case, I know my machine is fairly idle, so it grabs anything it wants. The nice thing is that if you're on a power machine, we have proper SMT threads, and that means that one processor is actually running, in this case, 4 programs at the same time. We also have an SMT8 setting for power 7, 8, and 9, I think, and power 10 in the future. So we actually have a CPU wrapper. Although the 2 CPUs are fairly busy at this point, we actually have a whole bunch of threads that we can activate or just switch to get the process to run on them. So there's a lot of hidden demand in here. And then as we go up to about 12 tasks running, we actually hit the top in here. And predicting how far this would have gone up and down in here is very hard to do. It's called latent demand. If you give it more CPU, those tasks will work faster and then actually tackle some more jobs as well. So you might guess, well, 3 CPUs would have done it. And when it actually turns out, if you give it 3, that will be topping out as well. And you have to give it 4 or 5. So we go back to my big chart. Now we're going to look at this top left quarter. So in here we can see this is the execution time, and we can see it's pretty consistently, it's between 360 and 380 milliseconds for it to actually run and capture all the stats. Going along in here, we start getting into our workload. Something happened here, don't worry, there's typical fluctuations on the machine. But when we get to here, we can see we're up at the 12 plus tasks. Now we've only got 8 SMT threads on our 2 virtual CPUs, 4 each. But we actually got to 12 before we actually sort of start using all of those threads, and we've actually hit the wall. And when that happens, we find that this is when njmon is actually struggling to get CPU time. It's going to get knocked off the CPU, somebody else will actually have some time, and then it'll get back on the CPU and try and finish off the collection of the stats. And we can see that running up into here till we've got 20. And this is about a third of a second. It's gone up to 1.2 seconds or something when it hit the actual top. Also, we find that if you have low amount of CPU, we'll do a sleep operation, waiting for the next time to take the data, and we come out of the sleep late. That's because we come out of the sleep, the process is scheduled onto the run queue and has to take its time to get actually onto the CPU. So this is called sleep overrun. So it was getting up to about half a second. It was waiting in the queue to try and get on the CPU before we could actually start running. So it's worth monitoring the sleep overrun as well. So this is a pretty good indication of actual saturation when this actually happens up the top in here. So this is probably worth measuring as well as our other stats. Now over here, this is my elapsed time between my actual snapshots. This is me allowing for the execution time and the sleep overruns. And when I first showed that to it's a worldwide company that's using njmon quite a lot, they thought something was wrong with the stats because it can't be consistent like that. The machine is really struggling, but njmon still keeping 1 minute stats coming in at a nice regular interval. And that's because we're actually using sleep to wait a particular number of seconds, and now we're using the micro sleep, which will sleep millionths of a second, so we can accurately wait up to the next boundary to do the next set of stats. Well, that's it for this video. I hope I've encouraged you to have a look at the Garage methodology. Lots of interesting stuff in the new way of doing development, and IBM's certainly has good structures and ideas on how to do that, quite radically different from me back in the day when I was a regular programmer. And also it's teaching some old dogs new tricks. Makes you reevaluate some of the things you're doing, and we can actually help out the new Garage methodology and the applications that come out of that. Now don't forget, you want to reorganize your applications for rapid development. If you want to keep abreast of changing things in your industry and your applications, new ideas that come out, you want that implemented in the application as soon as possible. None of this wait 2 years for the update to come along. Hope you found that interesting. If you did, give us a thumbs up. Don't forget to click the subscribe button if you want to be informed when my next video comes out. Thanks for watching.